Okay, so let's start our technical discussion for today. As I told you that today we'll be trying to conclude a recap of what we call pointers, right? And whenever you talk to students who have taken one course on programming, so if you ask them what is the topic you don't like, or what is the topic that creates some sort of fear in your mind, right? So almost everyone would say pointers, right? I don't know, to some extent it is true, right, that pointers are if you are new to programming, so maybe pointers are not very straightforward to understand, right? But today and maybe some part of next week, I'll try and explain to you that pointers are not as difficult as they appear, right? And one of your colleagues is asking me why this person seems scared. Well, this is actually true. Most of the new programmers, they actually get scared with pointers, right? Although there is no need, but still this is what the fact is, right? But with our discussion, we'll try and get rid of any such worries. Okay, so let me shift to the board and then we discuss pointers and we develop certain programs. Okay, right. So let's discuss about what are pointers, why they are important, and what we can do with pointers. Okay, so first let me write a fairly simple program which will have nothing, which you have been doing since day one of your programming, right? And then we discuss further. Okay, so let me just write two statements in the main. Okay, so we have an integer, let's call it x, and give it value 5. Okay, and then I simply display the value of x, right? So this is something maybe you did on the first day when you were writing your first program. Okay, so now as I keep telling you that whenever we are discussing something, it's always a good idea to see what is going on at the back end in the memory, right? So as I always do, I will draw a small chunk of memory, right, where all your variables are stored. So maybe it is something like this. Okay, now we have a variable x. We know it is an integer. Integer takes 4 bytes, right? So it means that somewhere in the memory, when you write x equals 5, so somewhere 4 bytes are reserved for you, right? And the value there is 5. Okay. Now we know that if I'm interested in this value 5, then this will be printed on the screen, right? But from your basic knowledge of computers, you must be knowing that every location in the memory has a unique address, right? So for example, when you are storing this 5 in memory, it has some address, right? I don't know what that address is, but I just assume, suppose that address is say 1000. Okay, I'm just assuming that this address is 1000. Okay, now since integer is taking 4 bytes, so it means one block that you see here. So we this particular one, this would be like 1004. Okay, because one block that you see here, this is like 4 bytes. Okay, so it means that this whole chunk is 4 bytes, and then you have 4 bytes here, 4 bytes here, and so on. Okay, so now suppose instead of this value 5, I am now interested in this address. Okay, that where is this 5 lying in the memory? Okay, so for that, what you do is, suppose you want to print that. Okay, so for that we'll see a new operator, right? You have already seen it, but in a different context, right? So if you are interested in this address 1000, not this value 5, then you have this operator, which is the ampersand symbol, right? And after that you write this variable name, which is x. Okay, so I explain it further. Suppose I simply write it cout. Okay, now let's discuss what is actually this and how is it working. Okay, so you see, we have previously seen this symbol ampersand, where we had seen it in function prototype, right? For example, you used to write like this, and we say whenever you write like this, it is call by reference. Okay, but now the same symbol is appearing in a statement with a variable. Okay, so the symbol stays the same, but now this symbol has a different meaning. This symbol has a different interpretation. And how do you read this? If this symbol ampersand appears with a variable in a statement, not in a function prototype like here, okay, then you have to read this symbol as address of. This is how you read this. Okay, so whenever you see this symbol with a variable, you read it as address of. So now what we have written here, we have written this symbol x. If you read it, it will become address of x. So you are simply reading it that what is this written in C++ syntax? It is written address of x. Now you see what is the address of x in memory? It is 1000. So if you execute this program, okay, I've just written a hypothetical value 1000. So this statement will print 5 and this statement will print 1000, which is actually the address in memory where this very value 5 is lying. Okay, and one important thing is that if you execute this program multiple times, okay, so every time you will see a different address, which is very much okay. Why is it okay? Because every time your program executes, it cannot guarantee that it will always allocate you exactly the same 4 bytes of memory, right? Maybe if you execute it another time, this location is reserved, another time this location is reserved, or some other location is reserved. So every time you will run it, this will be a different value, but this will be an address. And if you actually execute it, you will not see a number like this. Maybe you see a number like this, A23D. Okay, if you execute it, maybe you see something like that. So don't be confused that what is this. This is an address, but the only difference is that instead of decimal, it is written in hexadecimal, right? And I hope that you are studying DLD, so in that you have studied that there are different number systems. So what we use 0 to 9, this is a decimal number system, right? Then there is binary in which you have 0 1 only, and then there is hexadecimal in which you have like 0 up to F, which is 15, equivalent to 15, right? So if you see something like this as an address, don't be confused. What is this A? This A is actually 10, then B is 11, and so on. So this is just a number, okay? And this 0x which you see here, this is actually telling you that this number is in hexadecimal, right? So when you will run it, you will see something like that, right? But for our discussion, just to keep things simple, whenever I will write an address, I will be writing it as an integer. Okay, so let me just clean this and then we discuss further. Okay. Okay, now you see we have actually a variable. We know variable is in memory. If I want the value of that variable, I will simply write x, which is the name of the variable. If I am interested in finding where that variable is stored in the memory, then I use this ampersand symbol, right? This is called ampersand, and you have to read it as address of. Okay, address of, and whatever the variable is, you just replace that variable in this blank. Okay, and you should also be careful that the same symbol can have different meanings depending on where it is appearing, right? So I just told you that if the same symbol appears in function prototype, which we saw yesterday, then it will have a different meaning. It will mean we are talking about call by reference. But when the same symbol appears with a variable in a statement, then you have to read it like address of. So and x means address of x. Similarly, if I have another variable, say a, so this would simply mean address of a. If I have another variable b, this would simply mean address of b, right? So with this very small program, 3 statements, we are able to print the address of a variable in memory, right? So this is if you have any confusion till now, please let me know. Okay, so now let's rewrite the same example, but this time I'll be adding some more components to it, right? So previously I told you you have some integer which has say value 5, and I told you that you can use this to display the value of x, and you can use this to display the address of x, right? And at the same time we saw this, that okay, maybe if this is my variable x, it is in some memory address, let's give it a random address, say 5000. So this is the address 5000 and I have value 5 here, right? Okay, so this is what we saw in the previous example. Now you see the thing is that just printing the address is not something very useful. if I know it is at 5,000, then I don't care. Okay, well, what can I do with this 5,000? So simply printing an address is not something very helpful to us in programming. We should be able to do much more than printing, simply cout. So suppose I want to store this address somewhere, okay, in some variable, just like I store 5 in X. So similarly, now I am interested in storing this address 5,000 in a variable, okay. So the first thing that comes to our mind is that, okay, let's try this. Why not take another variable, let's call it P, it is also an integer, and then I can copy this address in variable P. Okay, this is the, we are just trying, maybe it is correct, maybe it is wrong, we don't know, but this is just a guess we are making that, okay, since it is an address 5,000, so let's try and store this address in another integer, we are calling it P. Okay, so it means now you are saying that this P will hold at value 5,000, but unfortunately this is not legal, this is not allowed. Okay, this you cannot do. Why we cannot do this? Because you see, this P is an integer. It can hold a value like 5, 10, 100, 1000, 1 million, anything, right? But what you are storing here, this is not a value, right? This is not a value. What is this? This is an address. So address is treated in a different way in programming as compared to value. So in other words, if I want to store an address, I need a special data type. I cannot store address in an integer or a float or a character or anything else. I would need a special data type to store an address, and that special data type is simply called a pointer. Okay, so if someone asks you in an interview, what is a pointer? There can be many fancy definitions that you will find in the books. But the simplest possible way to explain what is a pointer is this, you should remember. Pointer is a variable like A, B, C, X, Y, Z, but a variable that stores an address. This is the simplest possible definition of a pointer. Okay, what is a pointer? A pointer is a variable, but other variables store values, like X is a variable which is storing value 5. But when you say pointer, it is a special type of variable. It does not hold a value. It holds an address. That's it. Simple as that, right? I have not told you the syntax yet, but at a conceptual layer, what is a pointer? It is a variable that can hold an address. So it means this is an address, 5,000 in this example. I want to store it in some variable. So it means I need a pointer that can store this address. Okay, I cannot store this address in anything else. I will need a pointer. Now we see how you define a pointer using syntax of C++. Okay, so let's first see, maybe I write here, okay. You know, if I write this, how do you read it? You say A is a variable and integer is data type. Okay, so in other words, this statement is telling you that A is a variable, but the data type is integer. It means you can hold any natural number, positive or negative, within A. Okay. Now, if you have to define a pointer, the syntax would be very similar, but there would be just a small addition. How do we do that? We simply use a symbol, which is this symbol. With pointers, we use this symbol. Okay. Now you have already seen this symbol. For example, when you are doing multiplication, you are using this symbol. Okay. So since the number of symbols is limited, so that's why we have multiple interpretations of the same symbol, right? We know that if I write something like, say, A into B, it will means you are talking about multiplication. Okay, we are not talking about pointer. So be careful. Don't be confused if you see different meanings of the same symbol. It is okay, it is very much fine, right? I just gave you an example that this symbol you also use for multiplication, but the same symbol you use for pointer. How do we use it? We have not seen yet, I'll tell you, right? But the first thing you should be convinced is that one symbol can have different meanings. You just saw different meanings of this symbol, right? So now we'll see how this symbol behaves. Okay, so let's forget about multiplication. Let's come back here. Okay, now if you have to define a pointer, how do you do that? I need a variable which can hold address of an integer. So this is a key statement on which you should focus. This statement is actually defining a pointer. I'll explain it further. Okay. Now this, let's focus on this part only. Forget everything else. Okay. Now if you compare this with this int a, so I told you a is a variable. This is data type. Now this p is your variable. Okay, and this whole thing, int and star, this is your data type. Okay, so if you compare both of these, they are very much similar. A was variable, this was data type. P is variable, this is data type. Okay, now how do you read it? This statement looks a bit tricky. Okay, so I'll write it again on top of the board and we'll try read it. Okay, when you see a statement like this, you have to read it from right to left in this direction. Okay, means you just pick one symbol and read it. Okay, so you don't have to read it in this direction, left to right. You have to write it in the reverse order. Okay, so the first thing I see is p. So I say okay, p, this steric, if it is coming in a definition, okay, for example, if when it was coming here it was multiplication, if it is coming in a definition like this, then you have to read it as a pointer. So I read it, p is a pointer. Okay, I read p, I say p. I read steric, I say is a pointer. And then you have integer, so you will read it as to integer. So this is the correct way of reading it. I am just telling you how to read it. I have not told you anything else yet, right? So if you see a statement like this, you read it, p is a pointer to integer. Instead of integer, suppose I had something else. Suppose I have maybe character pointer c. You read it as c is a pointer to character. Now, still we are not very happy that what does this mean? P is a pointer to integer. So now you go back and you see what I told you, that what is a pointer. Now link this discussion with this definition. What is a pointer? Pointer is a variable that stores an address. So in other words, you are saying P is a, replace this pointer by its definition. You are saying P is a variable which will hold address of an integer, right? Means now in this P, you can hold not value but an address. But address of what? Address of some integer, x, y, z, a, b, c, anything, but it has to be integer. It means you cannot store address of a character in P. You cannot store address of a float in P, right? So you should be very careful before we move ahead. You should be very clear that how do we read it. Okay, I'll repeat it again, that if you see a statement like this, int star p, this steric or star, whatever you call it, you have to read it as pointer. Okay, but you have to read it as pointer only when we are defining something, just like here. Somewhere else it will have different meaning. Okay, so we are talking only if it is written something like this, and you read it in the reverse direction from right to left. If you read it, it would be like p is a pointer to integer. And if this does not make sense to you, you can also read it like p is a variable which will hold address of an integer. Okay, so this is, you can say, the compact way of reading it. But if you don't understand what is a pointer, in the beginning I told you pointer is a variable that holds an address. So you can also read it as p is a variable which will hold address of an integer. Okay, so now if we are convinced, we read it like this. So I'll just write one statement and then we can have a discussion session. So let me just write it a little more neatly. Okay, now see here. So here I'm saying int. Okay, so what we just said, p is a variable which will hold address of an integer. It means now in p I can copy address of any integer. I only have one integer in my program, which is x. So it means now this should be a valid statement. Now this is the key statement. Okay, because p can hold address, and we just discussed that. What does this give you? This gives you address of x. So now I can store address of x in p. If I have another variable, say suppose I have another variable y which is 10, then I can also do like this. This is also a legal statement. I can store address of y in p as well. But if y was a character or a float, then this would not be allowed. Why? Because in p I can only store address of an integer. Now it means that if you write this thing or you write this thing, both of these statements are actually giving you the same thing, which is address of X, which is this value 5000 in our example, right? So the summary of this symbol is that then I take your query is that there is something called a pointer. Pointer is nothing but a special type of variable. Why is it special? It is special because it holds an address. All other variables hold values, but pointer is a special variable which can hold address. Okay. And when you define a pointer, you have this symbol, static or star, whatever you want to call it, right? So if I want to store address of an integer, I need a pointer to integer. If I need to store address of a float, I need a pointer to float. Okay, so in our example, we are dealing with integer. So this statement here, it is defining a pointer to integer. You read it right to left. P is a pointer to integer. Or you can say P is a variable that will hold address of an integer. Okay, and then now you have P, you can copy address of any integer in P. Okay, and you already know that we have this symbol which gives you address of any variable. So if I write it with and X, it is like address of X, which is 5000, and I can copy that 5000 in P, which is a pointer. So you can now display address of X by writing C out P, or you can write C out address of X. Both of these statements will give you the same thing. Okay, so all the examples that we have seen, rather it was one single example, right? So let me just write those statements within the program, okay? So we don't have any functions here, so it's a very clean main. So I take an integer X, I give it value, say 100, okay? And we know that if we want to print value of X, so I can write value of X is, and I can simply write the name of the variable, I get value of X, right? But I told you that, okay, let's see what happens if I'm interested in address of X, right? So I told you you can use this symbol and this will give you address of X. So for the time being, let's not store this address in a pointer, just see what does it give you. Okay, so I will run this program and I'll share with you the output window. So I compile it, just give me a few minutes before it runs. Okay, now let me show you the output window. So you see, this is the output window. Value of X is 100. Address of X is, as I told you, it would be in a hexadecimal notation, right? So you see this FBB, FAC. So I hope in DLD you have, or you will soon see different number systems. So this number is actually an address, but it is in a different notation, right? So don't be confused. What is this? F is 15, A is 10, B is 11, and so on. Okay. So this is just a number. But as I told you, if I run this program multiple times, so by chance, it is possible that it gets the same value, but it is also possible that it gets some other value. Okay, so now I'm running it again and then I'll share with you the output window. So let me just run it and then I'll show you the output window. Okay, now let me see, where is it? Yeah. Okay, now you see, I have run the same program, but now you see a different address. Okay, previously it was D something, now it is B3F944. So every time you run this program, a different memory location will be allocated to this variable X. Okay, so that's why we cannot guarantee what would be the address. By chance it can be same, but in most cases it would be different. Okay, so now let's go back to the program and we try and extend our program further. Okay, so as I told you, it is not very useful that we just print the address. If we print it, we see it, we are happy, so what, right? Well, I should be able to somehow store the address in some variable, okay? So as I told you that we have to, whenever we are trying to store the address, we have to define a special variable, and that special variable is called a pointer. So how do we define a pointer? Since I need to store the address of an integer, so I will write int star p. Okay, so as I told you how to read it, you have to read it from right to left. So you will read this statement as p is a pointer to integer, or you can say, I will write it in comments here, right? P is a pointer to integer. If this statement does not make sense to you, you can also say it like P is a variable which will hold an integer. Sorry, not an integer, no, an address, which will hold an address. Okay, so both of these, this statement is actually telling you P is a pointer to integer, or you already know pointer is something which stores address. So you can also write it as P is a variable which will hold an address, right? But address of what? Address of an integer. Okay. So now once I have defined the pointer, I can copy in P address of any integer. Okay. I only have one integer in my program, that is X. So I can copy. So it means if X has some address, now P also has copied that value. And if I print the value of P, I should get exactly the same thing which I was getting when I write address of X. Okay, so let's see if it is true or not. So I say address of X using P. Okay, so what we have done, simply I have taken a pointer. This will hold the address of X, and I am now printing P. So you can guess that this and X and this P, both of these should print exactly the same thing. Okay, so let's run the program and see if it is happening or not. Okay, so let me share with you the output window. Yes, so this is the output window. You see, first we have value of X, which is 100. Then we have address of X, which is like 0059 something. And when I print P, I get the same thing, right? Because I copied the address of X in the variable P. So when I print P, I get the same thing. It is very much natural. Okay, so now I shift back to the board, right? And any confusion so far by looking at the program? If there's any, please let me know. Okay, if there are no further queries, let me just quickly write one more statement in the previous program, and then we will conclude the session for today. Okay, I'll not be writing main every time just to save some time. Okay, so I will just repeat these statements. Let me just change few variable names, okay, so that you just don't get used to the same variable names. And I say, so far we have seen this. Okay, but whenever you are dealing with pointers, it's always a good idea to see what is going on at the back end. So this is A, which is 10. This is say PA, right? And address of A, say I call it 7,000, which is here. And then PA, it gets the value 7,000. Okay, so the last thing I need to tell you for today is that you see, if I want to print the value of A, I know that, okay, there is a very easy way. I can simply write this cout A, and this will print 10 on the screen. Okay, but now we want to do something better than that. What do we want to do? We want to print this value 10, but not using cout A, but using this variable PA. Okay, it means that somehow using this PA, I need to print this value 10. Okay, so for the time being, for few minutes, just forget about programming. Okay, just think that you are trying to solve a puzzle, right? Or you must have seen those games where, like treasure hunt, where you have a clue and then you read it, you go there, you find another clue, and so on, right? So every small clue that you find, it actually links you to the next clue, and eventually you find the treasure or whatever you are searching for. Just think in that manner, that you are solving a puzzle. Okay, so you suppose you can't see this is hidden from you, and this is your first clue. Okay, you are playing treasure hunt, you come here, so this is saying go to 7,000. What do? You go to 7,000 and you find the value 10. Okay, this was a very small sort of treasure hunt, so we don't have a very long list of clues. But you see, if you relate it, that suppose you can't see this part which is in the red. Okay, you can only see PA. So you go to PA, you say, okay, what is PA telling me? PA is telling me go to this address, right? Just like in a treasure hunt, it is saying go to the library, go to the cafeteria, something like that. So PA is saying go to 7,000. Then You trust PA, you come here. When you go to 7,000, you say, okay, what is value here? Here value is 10. So you see, indirectly now I can access 10 using PA. I can go to PA, I see what is PA telling me. PA is telling me address 7,000. I go to 7,000, I pick this value. So for whole of this, whatever I have told you, there is a one small notation that will do this entire job. But the slightly tricky part is that this notation is same which you have seen previously, but now it will have a different meaning. Okay, so now let me just write it. Now will come what you were saying. Suppose I write this now. Okay, just focus on this one. We have seen this previously. Okay, where? Here. But here I told you how to read it. You have to read it as PA is a pointer to integer. It means when this symbol is appearing in definition, how do you read it? You read it as pointer. Okay, but when it is appearing like this, okay, this is a statement. Now this is not a definition. So again, the meaning of this symbol, they will change. Now you do not read it as a pointer. Now you read it in a different way. And how do you read it? Okay, just see carefully. I'll try and tell you. Suppose you have this P, rather it's PA. How do you read this static? You have to read this static as, let me just write it, contents of, right, contents of, then you have this way PA, so you write contents of whatever is in PA. I understand it's not very easy to understand, so I'll repeat it many times. Don't worry about it. Okay. So when you have a statement like this, static P or static PA, you read it as contents of whatever is in PA. Now, what is in PA? 7,000. So it means you are actually saying you are reading at contents of 7,000. You go to 7,000. What are the contents of 7,000? 10. So actually, this statement will print your value 10 on the screen. But how you will how it prints? This is how it prints. You should know how to read it. So if you have, I'll repeat it again. If this symbol static is appearing in a definition, you read it simply as a pointer. Okay, and you don't need to worry much about it. All you should know in this statement is that PA is a variable. It will hold an address and address of an integer. That's it. But later on in your program, if the same symbol is appearing with a variable, with a pointer variable, okay, PA, now you have to read it in a different way. How do you read it? You read it as contents of whatever is in PA. And if you want to simplify it with an example, I can write it as contents of 7,000. Why? Because PA has 7,000. So it is simply telling you, go to address 7,000. I come to address 7,000 and pick whatever the value is there. This is contents of. So contents of 7,000 are 10. So that's why this statement is equivalent to 10. Okay, I understand this is not very easy to understand. Okay, but don't worry, I'll repeat it with many examples in the subsequent lectures. But till now, if you have any quick query, please let me know, right? This I'll explain it again in the next lecture, so don't worry about it. But for the time being, if you have any queries, please let me know.